We have a huge method that is x is equal to a to the power a q plus r, a to the power q plus r, and b to the power p. And then we have y equals to a to the power r plus p into b to the power q. Similarly, we have z equal to a to the power p plus q into b by r. Sorry, into b to the power r. Then we need to prove is x to the power q minus r into y to the power r minus p into z to the power p minus q equal to 1. So we can directly use this formula, that is x to the power q minus r dot y to the power r minus p dot z to the power p minus q. And what we can do is actually use this value, the value of x, y, z, and put them directly here. So x is basically a to the power q plus r dot b to the power p into q minus r dot y to the power r minus p is basically the value of y is actually a to the power r plus p dot b to the power q into r minus p. And similarly, I'm gonna substitute the z with its value, that is a to the power p plus q into b plus b into the power r. That is a to the power p plus q dot b to the power r and to the power of p minus q. You can actually solve in individual term, that is first term equals to that, and then simplify this value into a form of a to the power a into b, and then you can do it. But since I have a huge space here, I am doing it in this way. So we know that x to the power n is if to x to the power n and then the whole bracket and then to the power n. If we have something in this format, that is the something that is for example 2 square gets then again cubed, that is we have a value of 2 square, we actually find the value and that value is again gets cubed. So the total value becomes 2 to the power square is basically 4. So 0 square is basically 4. So 4 cubed is basically 64. So we can also similarly write that 2 to the power 6 is also 64. That is basically 2 into 3. So we see that this power actually just multiplied with the existing power. So this value of x to the power n to whole power to the power again powered by n will be x n. So we are going to apply the same procedure here, that is a q plus r into q minus r dot b p q minus r. I guess I should make the bracket smaller because it's actually taking a lot of space, and clean up the maze from the side. So we're going to multiply this q minus r, and for sake of beautification I'm going to change the color of pen again, that is a r plus p into r minus p dot b to the power q and r minus p. Similarly, I can write the third term as x p plus q and p minus q dot b to the power r p minus q. So basically we can now multiply them and we will get the simplified value as a q square minus r square. I think I should write the a first because multiplying them is quite easy. So and this a is actually a r square minus p square, and the final a that is this a is actually equal to actually is equal to a to the power p square minus q square. And now I'm going to write the b part, that is b, if p into q is pq and p into r is actually pr, so we can write minus pr dot, again b into q into r is qr and q into p is minus pq, and similarly b into rp minus rq. So now we are going to actually use the multiplication of power method, that is with a different color pen. I'm going to show that x to the power n, but x to the power n is actually equal to x to the power m plus n. So we are going to use the same method here. So we will get x to the power q square, x to the power q square, x to the power a to the power q square minus r square plus r square minus p square plus p square minus q square, and we have actually completed the a part, and now we can write b into pq minus qr plus qr minus pq plus rp minus rq. So here what we can do is actually, now see if we can cancel something out. So here we have, let us start with the p because it is the first, it comes first in terms of alphabetical arrangement. So we have p minus p square here and we have plus p square here. So we can cancel them out. P square get cancelled out. Similarly we have q square here and we have minus q square here. So this q square and this q square also get cancelled out. Similarly there are minus r square here and plus r square here. So this r square also get cancelled out. So now let us move on to the b part. We get pq here, this is pq, and there is minus pq here. So the pq and minus pq get cancelled out again. And similarly they have minus qr here and we have plus qr here. So they are really close to each other. So you can easily cancel them out. qr and minus qr and plus qr get cancelled out. Similarly, rp minus rq also get cancelled out. So look, we have actually cancelled all the powers up and we end up with a to the power 0 and b to the power 0, because there is nothing left in the powers of a and b. So we get a to the power 0 and we know that a to the power 0 is equals to 1 and b to the power 0 b will be equal to 1 too. So we get 1 into 1, that is a total of 1, and this is the required answer, and it is equal to left hand side. Oh, actually I forgot to write left hand side, and so the teacher will, if you do the same mistake, I guess the teacher will be confused because what you are trying to prove. Okay, and that is equal to the we have the 1 at the answer, that is at the bottommost part, which is equal to the right hand side. We can write it as right hand side, and we can finally write that, since it didn't show that, I can write shown. I have actually shown that I can do this math and I have actually reached the right hand side. So this is how you basically do this math. It's a stream, this is only the one way, I guess, and it's a simple way, so I don't think you need another way to do this math.